Today I'm going to go over different Unit 4 Lesson 1 practice problems. Let's look at the first problem. This problem says triangle ABC is an obtuse triangle with the obtuse angle at vertex B. Angle A, therefore, must be. Well, what do we know about obtuse triangles? Well, we know that obtuse triangles typically look something like this. And we learned that obtuse triangles usually have an obtuse angle, one obtuse angle, and two acute angles. So if we know that vertex B is an acute angle, if we know the vertex B is an obtuse angle, then we know that it's greater than 90 degrees. Obtuse angles are greater than 90 degrees. If we know that our obtuse angle is greater than 90 degrees, well, then we want to identify what angle A must be. Well, if our vertex B is greater than 90 degrees, let's say it's 130, well then we can identify that we cannot have something that is greater than 90 degrees. What I mean by that is we know that all the interior angles of a triangle add up to 180 degrees. So if we already have one angle, an obtuse angle, that is 130 degrees, 180 minus 130 gives me 50 degrees. Well, if I know that I still have two angles left, but I only have 50 degrees left over to distribute between my remaining angles, specifically angle A and angle C, well then I know that I can't have anything greater than 90 degrees because I have to stay within the range of 50 degrees. That being said, I know that angle A must be at least less than 50 degrees in this instance. So let's look at our different answer choices. Less than 90 degrees. Well, it of course needs to be less than 90 degrees because if we have an obtuse angle, no matter what the measure of that obtuse angle is, then it must be, the other two angles must be less than 90 degrees. So that's a possible answer choice. Greater than 90 degrees. Well, as we just discussed, if angle A was greater than 90 degrees in the example shown here, we would go over the 180 degree interior angle limit, and so that cannot be an answer. Congruent to angle B. Well, if it's congruent to angle B, in this example, we'd have 130 plus 130, and that would give us over 180, so that can't be an answer choice. Congruent to angle C. Vertex A, or angle A, could in fact be congruent to angle C, but it's not required to be congruent to angle C. And it is for that reason that that is not an answer choice. Therefore, in every obtuse angle, or every obtuse triangle that we have, we know that vertex A, or angle A, must be less than 90 degrees. That is a requirement of an obtuse angle. An obtuse angle has one obtuse angle and two acute angles. Therefore, angle A must be one of those two acute angles and thus must be less than 90 degrees. Let's look at the next problem. This problem says, triangle QRS is a right triangle with the right angle at vertex R, and the sum of Q and S must be. Well, if we know that QRS is a right triangle, we can go ahead and draw it. So this will be 90 degrees. We know that right triangles are equal to 90 degrees. And I'll go ahead and label it. So this would be R. So I'll do Q, R, and S. Okay. Well, now we're going to see that what the sum of the angle measures of Q and R must be. Well, we already have 90 degrees. So what we want to do is we know the interior angles of a triangle must equal to 180. So we'll take 180 minus 90. And we know we have 90 degrees left over to manipulate or deal with. So 90 degrees must be distributed between the measure of angle Q and the measure of angle S. Okay, well, let's look at the answer choices. The sum of angle Q and the sum of angle S must be 45 degrees. Well, no, the sum of angle Q and the sum of angle S must be 90 degrees, not 45 degrees. Right? We have 90 degrees to distribute between Q and S. So if whenever we add Q and S, we must get 90 degrees because we're missing 90 degrees. So the sum isn't going to be equal to 45 degrees, it's going to be equal to 90 degrees. Greater than 45 and less than 90. Well, as we discussed already, the sum needs to be equal to 90 degrees. So that's not our answer choice. Equal to 90 degrees. That's correct. The sum of the measure of angle Q and angle S must be equal to 90 degrees. So this is saying when we add the measure of angle Q plus the measure of angle S, what must we get? That's what we're inquiring about. What would the sum be? Well, we already found out that the sum must be equal to 90 degrees. It doesn't matter what the actual angle measure of Q and S is. We're worried about the sum. So the sum must be equal to 90 degrees. Therefore, we can also eliminate D because D states greater than 90 degrees and less than 180. Therefore, our answer choice is C. Let's move on. This one says, triangle QRS has the angle measures shown. What is the measure of the obtuse angle? Well, if QRS has the angles shown, and we know that when we add all the angles together, we have to get 180, what we can actually do is do 1x plus 3x plus 6x equals 180, right? Because all the interior angles of a triangle must equal 180. Well, we need to combine all our like terms, so here we have 1 plus 3 plus 6, 10x is equal to 180. Now we're going to divide 10 on both sides to isolate the x. And thus we get x is equal to 18. Well, x is equal to 18. Well, we haven't been told which of these angle measures is an obtuse angle, but we can figure it out by substituting x into these different equations and figuring out which of them gives us an obtuse angle. That is an angle which is greater than 90 degrees. So let us see. So here we have 1 times 18. Well, that equals 18 degrees. So that is an acute angle. Now we have 3 times 18. I'll put that into my calculator. 3 times 18 will give us 54 degrees. So we also don't have an obtuse angle just yet. How about 6 times 18? Well, let's look at that. 6 times 18 equals 108. And so there we have our one obtuse angle, and that is angle S, which is equal to 180 degrees, which is greater than 90 degrees. And thus the measure of our acute obtuse angle is 180 degrees. Let us look at the next problem. This problem states, in triangle XYZ, angle Z is greater than the sum of angle X and angle Y. What must be true of triangle XYZ? Well, the easiest way to go about this is to read these different scenarios and think of different circumstances in which they may or may not apply. So for example, the first one says, the sum of angle X and the sum of angle Z is less than 90. Well, the sum of angle X and the sum of angle Z is less than 90. Well, then the measure of angle Y must be greater than 90. Why is that? Well, because if the sum of angle X and angle Z is less than 90, then we would have to have Y as our obtuse angle, because we need to at least get to 180. So, therefore, if we considered that, well then if the measure of angle Y in that instance would be greater than the measure of angle Z, right? Then we couldn't add the measure of angle X plus the measure of angle Y to get the measure of angle Z, because the measure of angle Y would be so much bigger than the measure of angle Z. And so if we added the measure of angle X and the measure of angle Z, we wouldn't get the measure of angle Z, or something less than the measure of angle Z. We'd get something greater than the measure of angle Z, because in this scenario, the measure of angle Y would have to be greater than either of those other measures. So that is not an answer choice. The measure of angle Y is greater than 90 degrees. Well, that's kind of similar to the scenario that we just discussed. We just discussed if we take the sum of the measure of angle X and the measure of angle Z, and that's less than 90 degrees, well then our measure of angle Y would have to be greater than 90 degrees, because we need to get to 180 degrees inside the triangle. And so that basically is just a reiteration of the scenario that we just saw. So we know that's not our answer. Angle X and angle Y are complementary. Let us remember that angle X and angle Y being complementary means that when we add them together, they equal 90 degrees. Okay, so if we know that they equal 90 degrees, then that means we would have the measure of angle Z is greater than 90 degrees, which is reasonable, but it's not something that's required of this scenario. It's not required that angle X and angle Y be complementary to each other in order to prove this fact true. So it's a possible answer choice, but it's not required in every instance. The measure of angle X and the measure of angle Y must be less than 90 degrees. Well, if the measure of angle X and the measure of angle Y is less than 90 degrees, let's consider that. Well, then we know that the measure of angle Z must be also greater than 90 degrees. Let me rephrase that, sorry. If the measure of angle X plus the measure of angle Y is less than 90 degrees, then the measure of angle Z must be greater than 90 degrees, because we have to get to 180 somehow. And that's reasonable, because in this instance, if the measure of angle Z is greater than 90 degrees, well then that doesn't change anything. If the measure of angle X and the measure of angle Y are both less than 90 degrees, then the measure of angle Z can in fact be less than 90 degrees or greater than 90 degrees, and it must in fact be greater than 90 degrees. So D is our most logical answer choice. Let's move on to the next problem. What are the possible side lengths of a triangle? Well, here we're given different side lengths, and we're asking which of these is a reasonable possible side length. Well, in this, we want to use the triangle inequality theorem. That tells us that the sum of the lengths of any two sides of a triangle is greater than the length of the third. Okay, well, the easiest way for me to go about this problem is to actually go ahead and divide up these different side lengths and label them A, B, and C. And what I want to do is pick an equation to use in order to identify or solve whether these are possible lengths. Well, what did I just say? I said that the third length must be greater, so my C, my third length, must be greater than the sum of my first two. So let's see if that applies in each of these instances. Let's look at the first instance. C would be 9, A would be 3, and B would be 5. So there we have 9 is less than 8. Is 9 less than 8? No, it is not less than 8, so that could not be an answer choice. Let's look at the next one. C would be 10, A would be 4, B would be 8. So 10 is less than 12. Is that correct? Yes, that's possible. So let us go backwards to see if this is true. So in order for us to go backwards, we want A minus B to be greater than C. So let's try that. A minus B. In this instance, I'm going to switch these around to B minus A, just so it's easier for us to calculate. So B minus A is greater than C. Okay. So my B in this instance is 8, my A is 4, and my C is 10. Well, 8 minus 4 is 4, and 4 is less than 10. So that's also true. So both of these are true, so that would be our answer. That is a possible length of my triangle. If I wanted to, I could go ahead and check each and every one of these. So I'll do it quickly just so we can see. "17 is not less than 15. Let's try the other one. That is not true. So let's try the last one. C is 18. 8 plus 10. 18 is less than 18. Well, that's not true. 18 is the same as 18 or equal to. So those answers are also not true. And so B is in fact our answer. Let's look at the next problem. This problem states, for a craft project, 4 students each chose 3 pieces of wire from a box. Which student chose pieces that can be used to construct a triangle? Well, let us just look at what we just were doing. We use this equation. And so what we want to do is identify our A's, our B's, and our C's. A, B, C, A, B, C, A, B, and C. And so what we want to do is plug all those into here and see which of them applies. So I'll color coordinate, so Dawn will be yellow. So we have 3 plus 5 is greater than 12. Well, 3 plus 5 equals 8. So 8 is not greater than 12, so Dawn cannot be correct. Let's look at Margot. I'll make Margot red. Okay. So 6 plus 8 is greater than 14. Well, 6 plus 8. Oops, 1 second, guys. Oh no. Okay. 6 plus 8 is 14. So 14 is less than 14? Well, no, they're equal to each other, so that can't construct a triangle. And now let's look at Sonji. She has 12 plus 8, 17, 17, 20. Is 20 greater than 17? Well, yes, that is in fact true. But let's go ahead and check Liam just to be sure. So Liam has 27, 16 plus 8. 16 plus 8 gives us 24. Is 24 greater than 27? No. So therefore, Sonji would be the student who would be able to construct a triangle out of the 3 pieces of wire that she selected. Let's move on. We have this one. Here we are given 2 sides, and we're being asked to identify what the value of x must be greater than. So in this instance, we're going to use a very similar problem, but just a little bit different. So A, B, and C. Now we want, let's do this, and then let's use our equation. 1 second. Our equation, or if we're looking for the missing side, we want to do B minus C, and we're looking for X, or what would be known as A, and then B plus C. So let's go ahead and do that. 15 minus 12 greater than A, also 15 plus 12. Okay, let's go ahead and put this in. 3A and 27. So therefore A, or what we also could call X, like we see right here, must be greater than 3, but less than 27. So it must be greater than 3, and so our answer would be C. Okay, next problem. Actually, that was the last problem. So I hope this was helpful, and I hope this helps you be successful on your own independent practice for Unit 4, Lesson 2. If you have any additional questions or concerns, please do not hesitate to reach out to me via my email, and I will help you.